Okay, I'm going to go over the answers here to the 1.1 quick check. Okay, first off, we're looking at a graduated cylinder, and then the graduated cylinder says record the measurement. So we have to look at it and say, okay, I see that there's a 300, I see 400, and there's 10 lines in between. So each of those lines must represent 10. So I can see that the bottom of the meniscus, okay, because remember we have a meniscus here, the water kind of sticks up to the side of the glass better than it sticks to itself, so it makes that scoopy side. And we always read at the bottom of the meniscus. So the bottom meniscus looks like it's right at 310, so I think 310 milliliters, or maybe you might say 311 milliliters. Both of those would be good. Okay, it says identify the estimated digits and the certain digits. So our certain digits, you know, the 3-1, definitely it's at the 310 mark. Okay, the estimated digit would be either the 1 or the 0. So we would say that this has 3 significant digits. Now the question that comes up, well, what if we had 310 milliliters? Okay, would that be a valid measurement? And I would say not. Okay, and the reason is it does have the right number of digits. It's 3 significant digits, but it's just the wrong value. You know, this 301 means that it's really close to the 300 mark. And I think somebody might make that measurement if they thought each line represented 1 rather than 10. So the idea really is about 310. Okay, second one, significant figures. Okay, so write the following measurements in standard, decimal, or scientific notation. Underline the significant figures. Well, let's do the significant figures first. So our kind of rules here are that significant figures, zeros at the front of a number are never significant. Okay, zeros at the end of a number are significant if they have a decimal point in the number, so those are significant. So here's zeros at the end, so all 4 of these are significant. These here, these zeros are not significant because they are not, they're not in a number that does not have a decimal point. Over here, all of these are significant, all of these are significant. Okay, so we're going to go back and put these in scientific notation. So a couple of steps to this. One is scientific notation is going to be a number between 1 and 10. So this number I'm going to say 3.55. And I'm going to put in a 0 because I want 4 significant figures. Now, if my number is less than 1, then I know that I'm going to have a negative exponent. So my 10 to the minus, and I can see I'm going to move it 1, 2, 3 places, so it's minus 3. Okay, 300.0, so I'm going to make this between 1 and 10. And again, I'm going to have all the 3 zeros because I want 4 significant figures, just like my number. This one is greater than 1, so I'm going to have a positive exponent on my 10, and I can see that the decimal point is moved 2 places. 186,000, so that's going to be 1.86 as my front number, and that's 3 significant figures. Okay, again, this is larger than 1, so it's going to be 1, 2, 3, 4, 5, so it's going to be an exponent of 5. Now going the other direction, okay, I have 4.20. Since it's minus 1, that means it's smaller than 1. So I'm going to move the decimal place to the left, 0.420. Okay, I want to keep that because of the 3 significant figures. And we'll put a 0 in front just so we know that that dot is a decimal point, not a little speck. And 1 times 10 to the 4th, okay, well that one, we're going to have to go to the right, okay, make it larger. So we're going to have to move it 4 places. So it's going to go 1, 2, 3, and 4. Now this one is problematic in terms of writing it as 3 significant figures. You know, I can put this in normal notation, but there's no way to show with this that these 2 are significant and that the other 2 are not significant. The only way to do that is to write this in scientific notation. Okay, last problem. We do a calculation. Okay, I've used my calculator and gotten the answer in the first place, but the idea is this top number, the 3200, that only has 2 significant figures, the 3 and the 2. The zeros are at the end, no decimal point, so they're not significant. The 4.184, these are all non-zero numbers. And the 5.83, those are all non-zero numbers. So those are easy to determine the significant figures. So our answer is only good to two significant figures. That means these two numbers are significant. Now I can't just write 13 as my answer because 13 and 1311, those are very, very different numbers. I have to add zeros in to hold the place. So my answer here is 1300. Okay, it's a two significant figure number, which is the answer to this calculation. That's it.